Hello, Statistics student. This video is for Chapter 8.1, Confidence Interval for Mean for one sample. So we are doing the second part of 8.1. So other than finding the confidence interval for mean, we can also think about what the sample size we want it to be. If someone tells us we want to restrict our margin of error to be a certain value. So earlier we discussed that if we want a smaller margin of error, we should have a big sample size. So of course, everybody know if you want to be more accurate, your sample size should be smaller. But how small? Oh, your sample size should be bigger, but how big? Should I do 2,000? Should I do 3,000, 4,000? So we would use the formula that we set up, that we know, that we learned from central limit theorem, to figure out how to do that, how much sample size is supposed to be, because sample size and margin of error are related by this formula. So let's use a blank, do I have a blank screen that we can use to do some work? Yeah, so let's use the bottom here, some blank space. This will be sufficient. So let's say, so we know that the margin of error for x bar is z alpha over 2 times sigma over square root n, right? Z alpha over 2 is the critical value where the confidence x, so this is like this one, the confidence x bar cut off with the non-confidence one. So this is a rare one, right? This is alpha, this is alpha over 2. And then so this is the cutoff. So we want to find, so you can see that they are inversely proportional. So if I want to find what n is supposed to be, if someone tell me what e is, so so this is like for planning purposes, we know if I have a sample and I know my sample size and I can find e, so they are, you know, they are kind of related. So how can I find e? How can I find n if e is known? I want to have a target of e. So I will square both sides. So this would be z alpha over 2, also square, times sigma also square over n. Because if you square this, you square this, you square this, the whole thing is square, right? So then we would multiply both sides by e, by n. Then we would say, okay, so I have n e square equal to z alpha over 2 square times sigma square. And then n would be, divide both sides by e square. So it would be z alpha over 2 square sigma square over e square. So sometimes conveniently written as just z alpha over 2 times sigma over e all square, because it's easier to do. Just multiply these two things, divided by e, and then square it. That would give you the sample size. And we usually round up so that the error is as low as possible. Okay, so this is what we did: z alpha over 2 times sigma over e square. But we don't have to do this by hand. The graphing calculator, the online graphing calculator, actually do it for us. So if you go to StatDis, you go to analysis. The first analysis is actually sample size determination. We are estimating mean, right? So you just need to provide your confidence level, your margin of error that you want to, because you haven't done anything, so that you can estimate your sample size when you're estimating mean. Okay, but you need to provide population standard deviation. Without this number, they can't give you. Population size you don't have to give, but population standard deviation you have to give, because this is how the error spread out. So let's do an example. A population standard deviation of a student's age in a community college is 15 years. So this is population standard deviation, that is sigma, is 15 years. If we want to be 95% confidence that the error in confidence interval estimate is within 2 years. We want the error to be 2 years. So this is E equal to 2. Sigma is 15. And my C level is 0.95. Oh, well, I actually have written it down here. So how many students must be surveyed? How many students must be surveyed, meaning what is the sample size? So I put all these in 95 to 15. 95, error is 2, and the standard deviation of the population is 15. We don't need this. We calculate, so it is 217. So if we interview 217 people, the error would be 2. So that is the end of 8.1, and we'll do 8.2 in the next video.